Welcome to Numbers in Space, Past and Future. My name is Bobby Seagull. I'm an author, broadcaster and maths teacher. I'm also an ambassador for the charity National Numeracy. So this National Numeracy Day, I'm joined by two very special guests to explore how we can use numbers in our universe. Firstly, I'd like to welcome Dr. Sheila Kanani from the Royal Astronomical Society. Dr. Sheila is an astronomer and the Education, Outreach and Diversity Officer at the Royal Astronomical Society. Welcome.
Hello.
I'd also like to introduce my fellow National Numeracy Ambassador, Jessica Gagen. Hi, Jessica.
Hi.
Jessica is the current Miss UK and an aerospace engineer, has a passion for all things space. She regularly visits schools across the UK as a STEM, that's Science, Tech, Engineering and Maths Ambassador. So today we're going to be exploring numbers in space, past and future. Now, you're both part of the space industry and science and maths go hand in hand. We know that using numbers is a part of all kinds of jobs, but I expect you might use numbers and maths frequently. And it's important that to use numbers, we feel like we can get on with them. But numeracy is something that we develop confidence and skills with over time. So I'm going to start with Sheila. So Sheila, you're a space expert, which is pretty cool. But I wonder if you've always felt confident using numbers.
Well, not really, if I'm honest. I've always enjoyed numbers, and I think I use them a lot in ways that I don't realise. So I like music, and I like writing books, and I like, looking at the stars. And you kind of don't realise how many numbers are behind all of those things. But at school, I used to find maths quite challenging, particularly at A level. And I just thought that because I wasn't good at maths, I couldn't be part of the space industry. But actually, when I started to relate the maths to the astronomy and to the space topics, that's when it started to make more sense.
Yeah, I love that concept of finding things that you enjoy and relating the maths and numbers to. And again, for me, initially it was football, but now it could equally be baking, which I'm not so good at. But yeah, maths in the real world. And Jessica, so you're an aerospace engineer. Did you have to put in a lot of practice to feel good about maths?
Yes, I really did. So going through school, when I was in secondary school, I actually really loved maths. I loved the problem solving element and that little buzz I used to get at the end when I worked my way through a question and I got the answer right. But then when I got to A level, I really struggled with maths. I struggled to keep up with the pace of my then new class, and I completely lost my confidence. And so I actually ended up dropping A level maths and assumed I would never be able to do anything mathematical related after that. I'd completely lost my confidence. And then it was a few years down the line, I thought, you know what? No, I believe in myself, and it doesn't matter if it takes me a little bit longer to grasp a subject. So I ended up studying a foundation year in physics, which reintroduced me to some maths. And then whilst I was doing my degree, I found the maths really hard because I didn't have the prior experience, the A level and the further maths A level, which a lot of my class had. And so I used to take time out of university specifically to teach myself maths. So we'd have lectures 9 until 6, and then I would stay in university until 8 or 9 specifically to practice concepts, because I thought it doesn't matter if it takes me 10 hours to learn a concept and it takes my friends 10 minutes. As long as I know it by the exam, that's all that matters. So
I really like the idea of people take their own time and pace. It's not like it's a race to get there. If you get there and you take a different route, again, the key thing is you get to that point where you feel confident with using maths and numbers. So thank you for sharing your story, Jessica. So as people can hear and see, our feelings about numbers and maths can change over time, like Jessica's just now, and Sheila's. And in life outside of school, we all need a bit of number know-how, whether you're planning to go to space or not. So Sheila, can you tell me what are some of the ways that astronomers might work with numbers on a daily basis?
It's so nowadays astronomers mostly use computers and robotic telescopes. They still sort of go out at night with a telescope and look at stars, but a lot of it is computer based now. So behind every computer program is numbers. That doesn't mean that you have to be the person that does the programming. You might have, you might work with teams of people that do the computer programming that then you can use. But I just think we are so unaware of how many numbers there are in our world, from using computers to using smartphones to using telescopes, even how those telescopes were invented in the first place, or working out the orbits of planets around stars, or ways of looking for planets around other stars. Everything has got numbers in, but that doesn't mean that you have to sort of excel in using those numbers, because normally as an astronomer or working in the space industry, you work as part of a team. So there might be people that just want to do the numbers and actually don't care about the space. And if you're working together, then it's a great place to work, and it doesn't kind of put you off needing to know all those numbers. But yeah, there is a lot of maths in the space industry.
Yeah. That's such a powerful concept that it's a collaborative effort, not just one person. So if you're maybe not as confident, someone else can help boost your confidence in the area. So Jessica, thinking about engineering, what are some of the other ways that people might use numbers?
Oh, there's so many ways, and it depends on the kind of engineering that you're doing as well. But for instance, you might be using numbers to figure out the load that a structure could take, or you might be using numbers to figure out the pressure inside a pipe. There's so many different ways of applying them, and for instance, in aerospace engineering, we need to model how air might flow over the wing of an aircraft, and the reason that we need to do that with maths is we can calculate what it's going to look like and then the drag that air may produce, and then because of that we can then redesign the wing to create less drag, which is really important because then in time that can then reduce the amount of fuel that we need to use, and it can make the aircraft more efficient. So there's so many different ways. On top of that, you've got elements of programming. You might have day-to-day bits and bobs of maths here and there, which is just stuff that you could do mentally, or it might be a bit more complex. But essentially, I like to think of maths being an international language, and it's so deep-rooted in everything that you do in engineering. Sometimes you don't actually realise that you're using it or why you're applying it. So lots of ways.
Thank you, Jessica. The international language, definitely, I can agree with that. So Sheila, thinking about the past and the future, have the ways that we use numbers in space changed over time? And I'm thinking about changes to technology and how we've explored the universe in the past compared to the way we're able to do now.
Yeah, that's an interesting one, because the answer's yes and no. A lot of the processes and the methods behind the maths that we use now are very similar to what astronomers would have used 2,000 years ago, 4,000 years ago even. And some of the numbers that they created that long ago were pretty accurate considering the lack of technology that long ago. So, for example, there were some ancient astronomers that realized that by looking at the angles of shadows in different places in the world, you could actually work out the circumference of the Earth. And we could still use that method to work out the circumference of the Earth, but we've got better ways of taking pictures and measuring distances and measuring angles and communicating with people across the globe, that we would use the same method, but because we've got better technology, we can do it a lot more accurately. So the methods have changed, but not as much as maybe you would think. And I think that's quite nice, because that connects us to all the other astronomers in the past that have kind of chipped away at that puzzle of not knowing what's out there, and added to what we know today. So another example is things like solar eclipses. So where the moon passes in front of the sun and blocks out the light from the sun. Ancient astronomers might have known that those were going to happen, and could work out when they were roughly going to happen, but wouldn't necessarily know the science behind it. So people used to think like a solar eclipse was the end of the world, whereas now we can really precisely work out when they're going to happen, like hundreds of years in advance, and we also know exactly why they're going to happen, and we can do science during a solar eclipse that ancient astronomers couldn't have done. So there's a real connection between the past and the present and the future, but it kind of brings everyone together rather than sort of saying it's better now because we have better technology, which is still true, obviously. I mean, the cameras and things and the space telescopes that we've got now are the pictures are mind-blowing and the things that we can find out about them are amazing, but we wouldn't have got to where we are today if the people in the past hadn't done the work as well.
It's interesting, like that all of us are chipping away at different bits and trying to reveal this ultimate space culture, which you'll keep on chipping away at. So, Jessica, what do you think one of the most exciting use of numbers is when thinking about space exploration?
I would say potentially in orbital mechanics. So we use numbers to calculate how we can change the trajectory of, for instance, a rocket traveling to the moon or wherever it's going in space. And we have to take into account that we are using, say, 99% of the rocket's mass just to break out of Earth's gravitational pull and get out into space. And then after that, we've got this little spacecraft. And we essentially then use the pull of Earth's gravity and centripetal force to be able to go around the Earth and create enough speed to then essentially slingshot to where we need to be to then fully break out of Earth's gravitational pull. And I think that's really interesting that we can use maths to predict that, because we can't exactly create a model in front of us because Earth is so big. Everything has to be simulated to begin with. And as humans, we've been able to use mathematics to do that, which just absolutely blows my mind, to be able to figure that out with different coordinates. And it really does, it blows my mind, and I actually studied it. So I think that's a really cool application of maths in space.
Oh yeah, that does sound incredible. And Sheila, what about you? What do you think is the most exciting use of numbers in space? It could be something that was used in the past or something we do now.
Well, this kind of overlaps the past and now. Something that blows my mind is to do with light travel time and how when you're looking at things in space, you're essentially looking back in time. So, for example, the light from the sun takes 8 minutes to get to the Earth. So if we, on the Earth, look at the sun, which you should never do without the proper equipment because that can be dangerous for your eyes, but if we were to look at the sun now, if you see it, you're actually looking at the sun 8 minutes in the past. And that applies to stars and galaxies and the universe as well. So if we were looking at a galaxy whose light travel time was 25 million years, we're essentially looking at that galaxy 25 million years in the past. And imagine there's aliens out there looking at us in the past. Are they seeing Shakespearean times, or are they seeing the Aztecs or the pyramids being built? And just the fact that those numbers mean that we're essentially time traveling kind of blows my mind a little bit. The other side I like is shrinking down the numbers to make them more relatable. So, for example, the numbers are so big in space, even taking into account like our solar system, it's hard to imagine how long it takes to get from like the Earth to Pluto. But if you shrunk the solar system down so that the sun was like the size of my head, the Earth would be about a peppercorn size, about sort of 7 steps away from my head. But Pluto would be like a grain of salt about 2/3 of a mile away. So the sizes just kind of make my head hurt a bit, whether that's a sun-shaped head or not.
Yeah, so when you see sometimes in textbooks, it can't quite convey the scale. But when you talk about the sun being the head and the Pluto being a grain of salt, like 3/4 of a kilometer, that is pretty mind blowing. So now, the ways of using numbers that we've been talking about require a lot of maths that we might study in school, university or beyond. But that isn't the case for all careers in the industry. There are lots of different jobs linked to space that we might not necessarily think about. For example, different types of digital or creative roles. So can we have a little discussion about these? So maybe I'll start with you, Jessica. So thoughts about different types of roles.
Oh, absolutely. So as people, we're all equipped with lots of different skills and we're all good at different things. And we need a mass spectrum of people to be involved in space because there's so many jobs there. So I've been to lots of space conferences, and whilst I'm there, I meet people who might work in marketing or even communications. We need some people as well to be able to bridge the gap between people who are scientists and engineers and people who aren't, because we need to be able to communicate with everybody what's happening, why we're doing certain things, and the benefits of them as well. And so there's so many different roles there which aren't necessarily heavy number based. And I think that's really interesting because growing up, I assumed that I had to be an absolute mathematical genius if I wanted to work in the space industry, but not at all. When I was out in the US last year at a conference, I met people who were there primarily to communicate, people who were there recording podcasts, and people who are just so integrated in the space industry and being able to let people know what was happening. I thought it was so cool.
Thank you, Jessica. And Sheila, how about you?
Yeah, I totally agree. I think if you love space, there's a job for you in the space industry. You could be a space artist, a space lawyer, a space journalist. You could be the person that creates the space suits, so you need to know about textiles and sewing. You could be a space vet, a space doctor. Basically, if you love something and you love space, put space in front of it and there is a job there for you. Like, I heard about this lady who had retired and got really into arts and crafts and making quilts and sewing. And then she actually got headhunted by a space agency because they needed someone to make the space blankets for the satellites. And now that's what she's doing. She's like 65 and she's working for the space industry. So literally, if you like space, there's a job there for you.
Yeah, it's incredible. There's just so many different ways that people use everyday maths skills in their careers. And again, some of my students will look forward to the day when there's space footballers, but we have to wait a bit longer for that. So we've got some questions, talking of students, from secondary school pupils. So first up, we've got a question from Hutton Grammar School in Preston, England. And they've asked, on a scale of 1 to 10, how important is maths in your day-to-day work and why? So maybe Sheila, this time I'll start with you.
Okay, so at the moment I'm working in education, outreach and diversity, and I'm an author. So I have used a lot of maths to get to where I am in my PhD and in my space industry work. But now the maths I tend to use are things like, I teach GCSE astronomy, so I do a lot of maths in teaching, but also it's things like working out, trying to work out sort of when I'm organising conferences or meetings, so it's like numbers of people and costing and sizes of rooms, and so it's more to do with kind of communicating different areas of maths and using kind of everyday maths than it is than it was when I was doing my PhD and working in the space industry and doing the programming. But again, it's sort of built into you. You use maths every single minute without even thinking about it. So on a scale of 1 to 10, probably about a 5 at the moment. But that's not to say that I don't use it. I just kind of use it without realizing a lot of the time.
Thank you. How about you, Jessica?
So for me, I'm pretty similar. So a lot of what I'm doing at the moment is educational outreach. So I'm not using a very intense level of maths. But having done my degree in aerospace engineering, there was a lot of intense maths there, but also knowing a lot of aerospace engineers who are now working in industry, I can speak for them in saying that it depends on your role, how much maths you're going to be using. So essentially, throughout studying that subject and doing the degree, they teach you a really high level of maths because they need you to know and be able to understand how it's applied in reality. So why are we actually doing this, and how would we solve this if there wasn't computers for us? But in industry, for us to be more efficient, be able to solve things faster, we do actually tend to use computer programs and things like that to solve things a lot quicker. It's just handy for us to know, for whatever reason, if something wasn't to work out, we could go, in fact, you know what, I'm just going to try and calculate this myself. So that's why we're taught those skills. But in industry, I've got friends who hardly use maths. They're primarily using CAD, so they're designing things, and the maths that they have to use, they can do mentally. It's really simple sums. Well, I have other friends who are working on things where they're having to use softwares like finite element analysis and things like that, where it would take so much time to be able to calculate just the tiniest calculation and run so many simulations of it that it's so much faster to let the computer do it. So it depends entirely on the actual job you go into after you've studied your degree, I think, how much maths you're going to do.
Thank you. Did he give me a number as well?
Oh, a number. At the moment, I'm going to say I'm maybe using maths on a 2 out of 10 scale, but then moving forward, when I go into the aerospace industry a little bit more, that's when that's probably going to change. It's going to go up a little bit.
Okay, thank you, Jessica. Okay, so we've got a question now from a Year 8 class at St Ninian's High School in Giffnock in Scotland. And they've asked, would it be possible to get people on Mars by 2050? And I'll start with maybe Jessica this time. So, would it be possible to get people on Mars by 2050?
I think so, yes, because SpaceX are making so many phenomenal developments in the aerospace world, and they've changed things. I mean, it's not just SpaceX. Boeing have got Starliner, which is going through tests at the moment. But everything that SpaceX are developing and the new rockets are there for us to eventually be able to go and colonize Mars. So I can see us launching rockets heading out there in the next 10 years, but then by 2050, I could definitely picture humans being on Mars. So fingers crossed, because that would be cool.
And Sheila, maybe on that same question, like, how do you think maths can help play a role in making that dream possible?
So it would be really, really important. It would take, well, so at the moment it takes about 6 months to get to Mars, but with a human crewed mission, you'd have to take a slightly different route because of the weight and the launch and things. So it would take a bit longer. So it's being able to work out how long it would take, how much fuel you'd need to take, how much food you'd need to take, and all those kinds of things. And at the moment, one of the ideas is the Artemis program, which is a moon-focused program. So if we can get astronauts to the moon in the next sort of 10, 15 years, hopefully, then that could be a stepping stone to getting to Mars, maybe using an orbit around the moon as a kind of gateway to then go on to Mars. So there's maths behind all of that. I do think at the moment, in theory, we've got the technology to get people to Mars, which is great, but I don't think we've got the technology to make sure that they can live on Mars or come back. So I know when I go into schools and I talk to young people and I say, who would like to go to Mars? And everyone puts a hand up. And I say, keep your hand up if you would stay there if you couldn't ever come back to Earth. And some people still keep their hand up. Okay. So, but yeah, I mean, again, with numbers for that, it's lots of testing as well. So we don't know. That's a really interesting thing about numbers, is that we're all learning at the same time. And we test it out, and we use different models, and then we use the moon as a stepping stone, and we learn from everything that we do as well. So hopefully 2050, and hopefully it's like one of the young people that we've spoken to, and we can say, yeah, we've met you and you're on Mars now. That would be cool.
That is very, very cool. So the final question from secondary school pupils is a Year 10 class asking, what's the most psychologically challenging aspect of living in a confined space for an extended period of time? So I'll start that with Sheila, and maybe again, how maths impacts living conditions for astronauts.
I think the most psychological aspect of confined spaces is who you're with. So the way that maths would feed into that, I'm hoping, is that when whoever it is, the space agency that's deciding who those people are going to be, they would do some kind of testing, so mathematical testing, numeracy, psychological testing on those people to check that they're all compatible. And that's, looking into how your brain works and looking how you problem solve and do teamwork and all of those kinds of things, so that you can live together in a confined space. And obviously maths would come into that quite a lot.
Thank you. And Jessica, how about you? Any thoughts on the psychologically challenging conditions of living in a confined space with other astronauts?
I would completely agree with what Sheila's just said. And then on top of that, I think it's important to remember as well that when you actually go to space, it's not a case of you've had 6 months of training. The astronauts are very well equipped, and they've been around their teams already, and they've been in simulations, and they're very used and ready for that already. So definitely on the psychological aspect, I think Sheila's hit the nail on the head there. She really has. Yeah,
because I was thinking, my family, we always loved astronomy as children, but I definitely couldn't share an extended space with one of my younger brothers. You know, we love each other, but probably not good for humanity's survival. So thank you to our students for their questions. So we've got one final question for both of you. I was wondering if you could share your best numbers in space, past and future fact with me. So a numbers in space fact. So maybe Jessica, you first.
Okay, cool. So, if we send astronauts up to the International Space Station, they'll experience microgravity. And essentially, the astronauts are actually always feeling the pull of Earth's gravity, but because the space station is going that fast, that's why they essentially float in space whilst they're aboard the ISS. And because of that microgravity, and because they're not feeling Earth's gravity as strongly as they would, they have to exercise a little bit more to prevent things like osteoporosis, but they actually are known to grow in space by up to 2 inches.
Wow.
And so, yeah, because they're not being as compressed, so to say, they're a bit more free. And so when the astronauts grow, the scientists and the engineers on the ground, before the astronauts have even gone to space, they have to take this into account when they're making their suits, but also the space seats aboard the capsules that the astronauts travel in have to be adjustable so that when they're traveling up, they're of a different size to when they're traveling down because they will have grown. And I learnt that whilst I was with the Boeing Starliner team, and they showed me the seats. They actually strapped me into one, and every seat is moulded for each astronaut's body. And then, as I say, yes, they have to take into account the fact that the astronauts are going to get a bit bigger whilst they're in space. So I think that's a really cool fact.
That's a great fact. That would probably wreak havoc with their welcome home party when they've got their suits ready. They've got to adjust it a slight amount. Thank you, Jessica. That's really great. Sheila, how about you?
Oh, I'd love to grow in space, by the way.
Me too.
Mine's kind of deep and might make you think. So, as far as we can measure, the age of the universe is 13.8 billion years old. And as far as we can measure so far, we think that there are 125-ish billion galaxies in the universe. So that is a big group of stars. There's billions and billions of stars. Of those stars, so far we've measured just over 5,000 planets, most of those within our own galaxy, the Milky Way. But how many known planets do we have with life on? Just the one.
Yeah, that's true. We should make sure we look after it as well.
Yeah.
So thank you so much, Sheila and Jessica, for joining us today. And again, I've learned so much. I'm going to share. I'm going to borrow and share your facts with people I know. So now, if you're watching along at school or home, I hope you feel inspired to begin exploring numbers in space for yourself. And you can download your free Numbers in Space Past and Future resources from the National Numeracy Day Hub. So we've got a brilliant activity that can help you work out your age on different planets, and another one where you can see time travel across the universe. So you can head to nationalnumeracy.org.uk/numeracy day to have a go now. So thank you so much for joining, and thank you again, Sheila and Jessica.
Thank you.